Hello, it is Monday, December 7th. So we are going to be working on checkpoint 6, which is Newton's third law of motion, and doing the third law CER today. So if you will go to your year view, you need to open up forces in motion. And we are on checkpoint 6, which is number 3, Newton's third law of motion. You're going to open that up. I'm going to be going over the definition, some examples from class. You will insert your own picture to help you understand Newton's third law, and then you will do an example from everyday life. So we are going to jump right in and start with a little bit of information about Newton's third law. So we're just going to talk and review a little bit first. A force. We've talked about this multiple times. A force is a push or a pull on an object. It is the strength or energy that moves an object. Forces result from interaction. So some examples of force that we've already talked about is friction. And friction resists motion, and it's that rubbing or sliding if you're pushing a box on the floor. Gravity, it pulls something down to earth. And then magnetism, which can attract or repel. So those are all different examples of forces. So just a little review about forces. Now, for Newton's third law, you need to know that forces always occur in equal and opposite pairs. And I have circled that on my screen. So go ahead and pause this right here so that you can type that in the definition. Forces always occur in equal and opposite pairs. All right. Another way to talk about Newton's third law is for every action, there is an equal and opposite reaction. So you could also put that for the definition and that was for every action, there is an equal and opposite reaction. So I will actually put that in this definition. Oops, we need the pen to go away. For every action, there is an equal and opposite reaction. So that can be your definition as well. Erase that. All right, so some examples we have here. An everyday example would just be walking, okay? You're moving forward and your feet are pushing back. So for every action, there is an equal and opposite reaction moving forward, but those feet are pushing back. All right. Kayaking. This is just an example you can use for class. So when you push the water backwards, that's the action. The reaction is the boat moves forward. So you push the water backwards, that's the action. The reaction is the boat moves forward. So for every action, there is an equal and opposite reaction. Again, forces always occur in equal and opposite pairs. Pretty simple. Next, I'm going to talk about momentum. So during the collision we've got some cars down here. So the momentum is the oomph or the strength of a moving object. During the collision of the force of the cars down here causes a change in the momentum of cars. However, the total momentum before is the same as the total momentum after the bumper cars crash. So we've got two cars who bump into each other. Again, equal and opposite reaction. Red car bumps into the blue car, causes the blue car to kind of go forward. So we've got car 1 and car 2. Car 2 would lose momentum and slow down. Car 1 would gain momentum and speed up, but the total momentum stays the same, just some transfers to car 1. And that momentum always staying the same is like the law of conservation of energy or the law of conservation of momentum. And if you would like, you can actually put the definition of momentum in the checkpoint, but it's not necessary. All right. All righty. Make sure that you have your definition, your examples from class, your picture, and examples from every day. We're going to go ahead and do this Newton's third law, CER. So we're going to watch the video together. And we are trying to answer the question, how is Newton's third law of motion seen in this video? So we're going to watch the video. All right, so we see in this video that I'm blowing up a balloon. There's a string, there's a straw on the string actually. I'm attaching the balloon to the straw and then I'm releasing the balloon. So what's happening here? So Newton's third law states that for every action, there is an equal and opposite reaction. So when the air is released, the action is that the air is blowing backwards. The reaction is that the straw is moving forward. All right. So our claim is that Newton's third law is seen in this video when the air from the balloon is released or let go, causing the straw to move forward. And our evidence is going to be from our video. So I'm going to say in the video, we can see the balloon releases, or we can see the balloon is being released and letting air out, which causes the straw to move forward along the string. Now, I know it sounds like we just repeated ourselves, and we kind of did, but our reasoning is going to explain how our evidence supports our claim. So we know that Newton's third law states that every action, we even said it up here, for every action, every action has an equal and opposite reaction. So this is where we're telling about the action, the reaction. The action is the balloon's air being released and pushing backwards. The reaction is the balloon and straw moving forward. And the balloon is moving forward because the air is pushing out, so it's going to propel forward, right? Think about anytime you blow up a balloon, you just let it go. That air is pushing out backwards, causing that balloon to move forwards. All right. So make sure that you have this information typed into your checkpoint, and you'll request feedback when you are finished. Other than that, have a fabulous Monday, and I will see you later.